let's calm down now. This looks a little intimidating. You know, this looks very weird. But let's kind of think about this. We want to get rid of the square root of n, right? Utilizing a u substitution. What can help me get rid of this? Well, you can get rid of it by treating it as a constant. So you can do that. That's an easier way to do it. You don't have to do the this, no. We could just use it as a constant. So what that would give me is du, and then we will have root n dx, which would cancel out the square root of n. A side note, x would have to equal u over square root of n. Okay. So now, when we do the u substitution, so this root n will now go away. We have 0 to square root of n now, just plugging in the bounds. And then 1 minus, and then x, let's see, x squared will give us u squared over n. To the power of n du. Okay. Now you're probably thinking, what now? So, well, this should sort of look familiar to you, right? This looks like one of those E formulas. If you don't remember, it's like the limit as n approaches to infinity, 1 plus 1 over n, and all that to the power of n. This is equal to E. Now, we have something weirder, right? Well, this is just, if you solve the limit, if you've done a lot of limits, things like this, you just let e to the ln, and then 1 minus u squared n to the power of n. This is just to like make sure, you know, sometimes I do this too, just to make sure what kind of e number it is. So this is, we can take the power out, and 1 minus u squared over n. So I'm very lazy. You can now take the limit here, right? And then you do like you do L'Hopital's rule, and when you do L'Hopital's rule, it'll all add up to like, you'll end up getting this. So the whole limit here. So now that we plug in infinity, when we plug in infinity, we will get 0 to infinity here. Square root of infinity is infinity. This whole limit that we evaluated becomes e to the power of negative u squared du. And this is just a Gaussian integral. So now this just equals square root of pi over 2. And that's your answer.